Okay, so good morning, everyone. So today is Wednesday, and this is week 4, So our topic for this week is para pala sa week 3. So it's okay lang if we're just 1 week behind lang sa schedule. Wala pa man siya. So before I would like to begin with our lecture today, I would like to remind some reason ba lang na I will not accept ng submissions elsewhere except sa drive ng libro sa Google Form. The main reason is ang task management pala is very typical. Unlike if all files siya, all submitted works siya are in one place nang hindi mo lang isama ng part mag-manage sa mga files, mag-check, mag-comment, whereas kung malantaw kami sa individual na DMs or personal na messages ng students ka, pag-reply natin siyempre mas scroll down na kami kung di na ito na yung nagalong tapos hassle ka tama sa pag-manage some quizzes. So that's the reason dapat sa isaragitan sa directory ang files. It's a matter of lang yun, management ng part. Kibutay siya tama. Kagka-hassle, especially kada tatlo ng sections na. Okay, so other matters. Wala namang kumay nag-mention lang yun ng other matters. Okay, so if you have any questions, comments, or suggestions, you can comment here in the chat box or DM me personally in the messenger. Okay, so let's start our topic. Let's review the night a bit so as discussed. So first week we started with rectilinear motion, wherein the motion is along one axis only. Bali, ang iyang motion in a straight line lang siya, in one axis. Pero it has many behaviors kung paano siya mag-move along that line. It can move constantly, in constant motion. It can also move with a constant acceleration, or it can move other than these two types of motions. So we categorize as 1, 2, and 3 category. So category 1, category 2, we have derived the equations, and for category 3, we cannot derive all because for category 3 is this behavior motion for literally infinite type of motions. So we cannot, of course, know all the formula for category 3. Except for category 1 and category 2, which is uniform motion and uniformly accelerated motion. So that's for one. That's the recap for the week 1. For the week 2, basically the same again. Ginatagan na one axis, bali primero week 1, isa lang axis. Then nag-add another one axis. Isulit na lang. Bali kung nag-move mo na ang other axis, kung nag-move ang object in 2D space, we are not studying or we are not observing its 2D motion. Rather, we are observing its components. Anong yung behavior if viewed from this axis? Anong yung behavior if viewed from another perpendicular axis? Ano talaga mag-analyze mo? Ina-project kaya ang motion sa line axis. Tapos ina-analyze sa individual components. Because it's very difficult to analyze along the path. Imagine complicated sa math kung i-analyze mo siya along the path. But actually there are other also frame of reference or coordinate system to analyze depending sa sa advantage to disadvantage versus situations of motion. Okay, so last week we used rectangular probability system to analyze the x and y components of the 2D motion. Category 1, category 2, category 3 nga motion. Today, i-repeat na siya ako ng, but instead, we use another type of coordinate system, which is under most of the curvilinear motion, pero we can use normal and tangential coordinates. So, let me transfer that inside. Okay, so week 3. Excellent. Curvilinear motion using normal and tangential components. Sorry morning, I'm sorry to interrupt you, sir, but hindi masyado audible yung audio. Sige, thank you. Test na siguro. Basihin na lang konti. Okay? So first test, hello, good morning. Second test, hello, good morning, which is much better. First or second? Sir, katunog sa background. Second, sir. Actually, wala tuloy sa background ilan na siya, behavior, emotion. Itunog ko na lang tingin ko. Okay, sige. Okay, so let's draw a 2D axis. Pero ipakita ang x and y components, ipakita naman ang n and t components, n for normal, t and for tangential components. So, for example, let's draw. Of course, this is the traditional x and y components. Then we have, again, an object, and it has a trajectory of motion, something like this. For example. Sometime later, an object having this, let's say, so, ano ganito ba natin yan is velocity ganito of an object, which is, when we say velocity, that's the resultant. No? It is always tangential to the path. So we should draw the example. That's a tangent sa path. Oops, hindi siya masyado tangent, but sila tangent siya sa path. Now, this is the resultant vector, meaning this is the original. This is not a copy, or this is not a part, but this is the whole. So we can have an infinite pair of components, because infinite pair because pwede mo i-vary ang dual legs, pero ang sum nila, ang vector sum nila is still the same, still that vector. Okay, so one pair is, of course, natin nga ng rectangular component. For example, you have to draw here. Muli natin nga y, natin v x. Okay, so the sum of these two vectors is the original vector, which is the resultant vector v, which is tangent. Another one is, for example, we don't like this perspective here, we don't like this point of view. Rather, gusto tayo ang norm tangential. So, anong siya normal? So, siya normal, critical siya tangent. Of course, tangent. So, ara naman dali since velocity is Tangential is in axis. Along that is ano na ito, tangential axis. Now, kung i-translate ko ang x and y, dali ko na yun. Translate ko the example lang. Ano yung x and y? X and y. Right? Now, ang inisayaw ko yung string relation. This is the tangential axis because velocity is tangent to the path. Then its direction along that is known as the tangential axis and perpendicular to that, of course, because ang dual axes are always orthogonal. This one is the normal axis. So nag-add lang tayo another coordinate system sa object of consideration. So, do nag-garot siya kumay, but actually hindi na siya garot, especially if i-remove yung x prime and y prime. So this is for velocity pa lang ng meron kita. Ang interesting na part is sa acceleration ng part. Ano yung itsura sa normal pag tangential na component sa acceleration. Complete ko na lang details para namin. So, of course, ang siya natin nga ay sorry sa lang. Yung sa itong position R. That's also tapos of course ito nga ang x component of course this is the v which is equals to dr dt, change in position. Ang velocity pag ang position r, it doesn't have to be perpendicular. Why na sila sa amo ng hard rule? Pinaderive na pagkita naman nila sa time to lang second part na primero ang maging R1 may final prime. Ang second part naman sa yung velocity, but in this case average velocity transfer because you have only two states. You have two states, you have two stated points. Now if we approach that to this time infinity is very small, then this second line approaches tangency, but it doesn't have to be perpendicular. Okay, so that's the relationship between position and velocity, and we just have shown only in our normal tangential axis. Okay, let's go to tangential axis. Let's go to acceleration. Sorry, so that's for velocity. What about for the acceleration? So, ako Japan, kita talang sa Japan. Dito ko para sa velocity. So, kung ano yung velocity, kung sa madang x, madang y, ng acceleration, which is the resultant vector also. What we have learned the last time sa rectangular component is that actually wala ito na discuss but sa dining topic discuss there are many types of acceleration depending kung diin siya na axis na project. Okay. So kung sa normal axis it's called normal acceleration. Kung sa tangential axis it's called tangential acceleration. Okay. So this is EN and AT. A plus in my arrow, that is a vector sum. It indicates only that the sum of the normal acceleration and the tangential acceleration is the resultant acceleration. It is also equivalent to AX and AY, correct? Because this case EX is the acceleration along x-axis, AY acceleration along y-axis, but the vector sum of these two pairs will always be the same, which is the original vector, the acceleration A. Meron yung di isa part. Sulat na lang sa sumong, pero hindi ito yung topic. Next topic, which is radial and transverse data. Isa data. Pero muna natin na focus of consideration for today. In normal acceleration and tangential acceleration. What are these? And what are the characteristics of these accelerations? And one effect velocity. Okay. First, let's focus on this tangential dynamic. Tangential acceleration, by the word po lang, it is acting on the tangential axis. So if this is our v and velocity is tangent to the path, therefore the axis is collinear with the velocity. This is our t. And we have tangential acceleration, therefore tangential acceleration is also along this direction. But it can have two directions. The acceleration siya, pwede siya deceleration, di ba? So pwede siya ka-up in two ways. Pwede siya ka-up in this direction, pwede mo siya ka-up in this direction. But its direction is always collinear with the velocity because ano ganun, tangential acceleration sa tawag. And the velocity is obvious na siya, na tangential na siya. Wala pa na sila natawag tangential velocity, but automatic na sila pag velocity, tangential na siya sa path. Sa path, okay? Tangential at that point. Alright? So, ano ang purpose ng tangential acceleration? Anong i-effect sa velocity? Well, natawag mo, either directly opposite siya or directly with the velocity siya. Therefore, it is responsible for the magnitude. Because if you think of it, velocity is a vector. It has two parts. It needs to have magnitude and direction. So velocity, ito we know that velocity is equal to magnitude plus direction. That is the composition of velocity. It has magnitude and it has direction. And we know that ang acceleration responsible for velocity, but we need to be specific because velocity is composed of magnitude and direction. Kung may change yan, either let me say na may acceleration na siya, automatic. So kung may change yan sa magnitude, pero wala change in direction, meaning diretso lang siya, pero hindi siya, nag-gases. So nag-change in magnitude yan, therefore there must be tangential acceleration. Can you change yung magnitude yan? And tangential acceleration is responsible for the change in magnitude. Okay? What about direction? What if ang magnitude yan constant, despite the curve, ano yung path? Curve yung path, meaning halin yun, pakanto daw, dun sa lugar siya, constant yung speed. Therefore, wala pa siyang tangential acceleration, yung magnitude yung fixed, constant. Wala ka rin kasi wala ka magnitude. But the fact nga, they change the direction. They change it, di ba? Ang curve, di siya straight. The fact na ang direction nila constantly changing, therefore there must be another type of acceleration which is called normal acceleration. And this acceleration is responsible only for changing the direction and not for the magnitude. So specific siya ng that. Okay? So tangent or the change in magnitude. And the formula for tangential acceleration is actually anything. Siya din siya. Kaya diba sa velocity ko natawag ang formula na ito sa velocity depende kung ano yung mga category. Kung category 1, dx dt automatic. Or delta x, delta t kung yung mag-range. Kung category 2, ang formula sa velocity tayo naka-attach para sa top, diba? 3. Meron ito set of equation 3. Yung velocity ito, diba? Final velocity minus initial velocity equals to 80 and so on. Tapos sa kabila. Yung velocity niya naka-attach sa equation na may arasa acceleration. Pero kung ang acceleration is set to 0, ma-reduce na tatlo ka equations into dx dt. For velocity initial equals to velocity final. Buti ang ito is sa category 1 and category 2. Sa category 3, of course, any form ng atomic equation. Ang similarities ng AP and VP is very similar, that this tangential acceleration can have the form of category 1, category 2, and category 3. So for category 1, of course, the acceleration is 0 here. For category 2, acceleration is constant. So automatic may tatlo itong equation na nagkaroon. For category 2, acceleration is variable. Therefore, wala ka sa specific therefore, ang formula for tangential acceleration depends on the type of motion. Na-identify na every problem, a motion is an object is constantly moving, blah, blah, blah. Identify mo kung ano siya type of category. This na ginawa. So, ang equations to, para to siya sa tangential acceleration. Whereas a normal acceleration, which is responsible for direction, it has already defined the formula that is equivalent to v squared over rho, or rho is the radius of curvature. Kung mag-encounter dito yung curvature, lain pa yun sa curvature K is the reciprocal of radius of curvature. Technical jargon. Okay. So radius of curvature, they are different. Pero sa normal acceleration niya, ang denominator is the radius of curvature. So for normal acceleration, we have a formula for that. For tangential acceleration, it depends on the behavior of motion. Oops, why ko pa na-drawing the acceleration? Drawing the acceleration. It's just, let's do it. So in this case, for example, the ring point, harap ata sa inflection point. If you can remember sa calculus, an inflection point, this is the point at which the line changes its direction. Ang tangent line there, imbis na going clockwise na clockwise, it changes sa counterclockwise. Ang point na, that is an inflection point. That is the point at which the rate of change of the slope is 0. Okay, 0, positive, 0, negative. So yun siya, assuming this is also inflection point. So inflection point may tangent po yun siya. So ang acceleration to the, let's say deceleration deceleration A. So ginawa po siya. So sometime later, mabra to the tatlo ka point ng prediction. So acceleration is opposing to velocity, therefore ano itong velocity magamay. So paglabot sa punta mo, sabi ang model na siya. Tapos diri, mo na siya. Diri gamay na gud. Okay? So mag-visualize na lang ang aton nga velocity. Mag-drawing kilowatt for acceleration. Ang acceleration kaya hindi na siya mag-change sa magnitude. I-assuming na sa category 2. Example lang. Hindi ko nga mag-drawing ka na. During the case, may initial length po. Muna sila po. Diri mo na sila po. Ang kalabaon niya, ang iyang magnitude rather. Muna dyan po. So constant. Kaya ato yung category is type 2 category. Ang ato yung acceleration, which is in this case, deceleration is constant. So in effect, ang tangential velocity na pagamay. Okay? Now, include the normal acceleration. Let's draw it in green. Normal acceleration is tangent, correct? Normal to tangent. So sa ganyan case, we're going to do. Alright. So sa ganyan case, nagkakabalo ko na mag-YouTube. Drawing ako na axis. Now, kung lang taon magnitude is ano, b squared divided by rho. Now, kung lang taon ang b, nag-change. Pero meron at this point, katakot sa b. Spin, nagamay naman. But what about her law, which is the radius of curvature? Let's assume na lang for simplicity's sake, no, ng iniya arc is circle. Para natin ng law is constant. Okay na? So, ang ating radius is constant. So, constant na siya. So, formula tayo ang numerator na is V. So, V squared. So, sa inyo case, ako niyo, therefore, ako man normal eh. Ang order ang, let's say, natin yung AN. So, hindi naman ako magumay. So, let's say, yes, yung makalitis mo natin yung AN. Hindi naman, magumay naman natin yung relation. Ay, sila. Constantly. Let's assume na lang ano siya, going straight line para ma-justify ko ang assumption. 3.2. Oh shit, 10 minutes. Going straight line siya. Shit! Going straight line siya. Kung going straight line siya, ang radius of curvature is approaching infinity. So if the denominator is approaching infinity, therefore AN is approaching 0. Gagamay sila na gagamay. Justify ko ako ang drawing. So 3 gagamay sila gagamay. 3 gagamay. Until such time na ready atong particle ang atong normal acceleration is obviously dapat 0. Straight line ka naman, wala ka nag-change direction. Dapat na ang normal means di ba wala ka nag-change direction kaya straight line yung path. So I hope na discuss ko ang concepts ng normal tangential acceleration in terms of components. There's another part pa din na i-include ano na siya ang projectile motion. Of course, projectile motion is a special case of general curvilinear motion. Kita ito ang normal sa tangential components. So, this is projectile. Let's pick up 5 points now. 1, 2, 3, 4, 5. Okay. So, ano ganyan characteristics ng projectile motion? We have acceleration in y direction only, which is gravity. Ax is 0. Therefore, lain ang equation for y direction, lain ang equation for x direction. Okay. We have 3 equations here for this. We have only 1 equation for this. The fact that ay is constant, which is g, always acts downward at any point in the trajectory. That is g or a1. And this is resultant, diba? This is the original vector. Now, if we analyze its components in x and y, so obvious na I don't know, tapos na. Ax is always 0, ay is always g. So, wala na matala additional insight. But if we analyze it from the point of view of normal and tangential axis, natawag na ang components na nagpapari. In this case, ang mga itong tangent na itong normal, this is EN, this is AP. This case naman, ang itong AP, ang itong normal, laba naman ang normal ta. Kasi di madugang ako ito para makita ko nga ang atong AP nagamay na din. So normal ta, nag-approach G until 3 ang atong AY, which is equivalent na sa normal, and so on. Naglabat ko sa pata. So kung analyze mo na tawagan na, kung drawing ko di velocity, at the point of firing din, from the point of firing pala niya, may mga velocity yan, may nag-approach niya ang acceleration, from the component of gravity, Ikinatawag ko ang gravity mo. Sobrang sa component, ang isa real component to. This is tangential acceleration. Opposite sa velocity. Yung at the point of firing plan lang, start of firing plan lang, may just sub dun sa decelerate. That's why hindi siya forever nagkasaka. Ay pumiro pa lang niya, nabuhin na siya. Pero ang ato na 80 is not constant para sa category 2. Natawag lang ang drawing. Ang 80, ano lang yan. Ano lang yan. Until sa pinakatapos, ang tangential acceleration is 0 by the look of it pala mo. Kung paano siya perpendicular lang. So 0 siya. Therefore, ang ato na 80 is variable. It's very difficult. But it can be learned mathematically kung ano na siya. Kung ano na siyang yung form, kung ano na siyang function. But to solve projectile motion using this one is impractical katama. That's why we analyze the motion of object by its projections in two perpendicular axes. Kaya kapag mag-analyze, magtulog kung isa siya path ba lahat. Kaya ang difficulty lies in your framework which is constantly change man yung way of seeing. And like yung sample being may isa diyon, may isa mo din, ang frame of reference is absolute, wala nag-change. Ang nag-change yung object bigla na show nila. So, post siya yung analyze. So, like yung hari ka man diyon, mag-upload naman to sa object. Ikaw mismo ang nag-change, hindi yung object, yung sunod yung object, it seems to be constant. So, bigla yung general framework of measuring. Wala tayo-analyze along the path. Hindi analyze kaya ang projection sa velocity or acceleration in two orthogonal axes. Sa 3, ipakita ka na ang tangential acceleration sa projectile is para sa category 3. That's why nagagumay until ma-reach ang pinaka-top na 0 ang tangential acceleration at that time. Now, kung natuon pa, nag-reverse na di siya. Kulabot yun, ang acceleration mo, sige, with the direction of velocity siya. That's why kulabot yan. Sige. This is the reason na ang muna characteristics ng projectile motion. It's because of this tangential acceleration na component na siya sa gravity. What about normal acceleration? Well, normal acceleration is always inside of the curvature. Siya na ang nag-produce ng torque. Yung AN. Siya na aral sa. Siya na nag-push sa atong object. Siya na nag-curve. Kumbaga, siya na yung sculptor ng mga normal acceleration. Siya na nag-design frame na path. Okay, that's all for projectile motion. I think I've covered the what is normal acceleration, tangential acceleration, and their effects on the general curvilinear motion, especially on the pragmatic part, which is the projectile motion. Additionally, meron isang formula na ito. Kita ko lang. Right. So the radius of curvature is equal to 1 plus first derivative is 2 raised to 3 over second derivative. Okay, let's check. So if you have a function, let's say y as a function of x, you can get the radius of curvature at that point given the function. So you need to derive the function first time, the second time, and then you plug in this equation, you will get the radius of curvature at that x. Try ito siya sa first problem. But for now, take off ko na lang siya. Mas stop ko. Let's continue na lang.